So we're going to graph the two equations, y equals negative x plus 3 and y equals x plus 5. So I'm going to start with the y equals x plus 5. So I'm going to plot my y-intercept. My slope is positive 1, 1x, so I go up 1 and over 1 throughout my whole graph. And I keep going so I can identify all the solutions that are possible. Okay. And then I'm going to do y equals negative x plus 3, so I'm going to start at the 3. And negative x means I'm going down 1 over 1 because my slope is negative. And I'm going to graph this line all the way throughout. And we should notice one thing, and that is that these lines intersect right here at negative 1 and positive 4. So I can say that the solution is negative 1, positive 4. Now, today we're going to learn about another method of solving systems of equations, which is solving them algebraically. If you notice, both of these equations are equal to y. They're both equal to y. Y is the same variable. It carries the same value for both equations. And they are both equal to y. Because they are both equal to y, that means that they are equal to each other. And so I can say that if negative x plus 3 equals y, and x plus 5 also equals y, that must mean that negative x plus 3 has to be equal to x plus 5. If they're both equal to y, they're both equal to each other. And because they're both equal to each other, I can solve for x. So I'm going to add x to both sides. And I'm going to get 3 equals 2x plus 5. And I'm going to subtract 5 from both sides. 3 minus 5 is 2. Is negative 2. Negative 2 equals 2x. Divide by 2, and x equals negative 1, which is the same as where we said they would intersect. Now, if I take that negative 1 and I plug it back in, and if I say y equals negative 1 plus 5, well, negative 1 plus 5 equals 4. And if I said y equals negative 1 plus 3, negative is a positive, so 1 plus 3 also equals 4. And they intersect, and I'm going to say y equals 4, they intersect at negative 1 and positive 4. So this is just another method. We have graphing, and we call this solving systems algebraically.